Okay, now we're going to continue our discussion of extrema. An interior point of the domain of a function f, where f prime is 0 or undefined, is called a critical point of f. Now in the last recording we looked at graphs where we had f prime equal to 0, and sometimes we had maximum minimums there and sometimes we didn't. But in order to have a critical point, a place where our graph may have a maximum or minimum, f prime is going to be 0 or undefined. Now if we want to find the absolute extreme of a continuous function on a finite closed interval, we need to find all the critical points and then evaluate f at the critical points and endpoints. The largest and smallest of these values will be our absolute maximum and absolute minimum values. Now let's take this example. We want to find the absolute maximum minimum values of f of x equals 10x times 2 minus natural log of x on the interval from 1 to e squared. Now the first thing I'm going to do is I'm going to go ahead and distribute this so that we won't have to use a product rule more than once here. So 10x times 2 is 20x. 10x times natural log of x is negative 10x natural log of x. Now we are still going to have to use the product rule, just to make it a little bit easier on us. Now let's take the first derivative. The first derivative of 20x is just 20. Now here this is a product rule, so that's going to be minus 10x times the derivative of natural log of x. Now notice this was a minus, so I need to carry the minus sign through. So minus natural log of x times the derivative of 10x. Now that will give us 20 minus 10x, and remember the derivative of natural log of x is 1 over x, minus natural log of x times the derivative of 10x, which is 10. So that will give us 20 minus 10 minus 10 natural log of x. 20 minus 10 is 10, so I have 10 minus 10 natural log of x. Now in order to find the critical values here, I'm going to take that 10 minus 10 natural log of x, and I'm going to set it equal to 0. And move my 10 over, subtract 10 from both sides. I'll have negative 10 natural log of x equals negative 10. Divide both sides by negative 10, and we have natural log of x equals 1. Now remember, the place where natural log of x equals 1 is at e. Okay? Remember the way we compute that? Our base here is e, and we say e to what power gives us e, and that will be 1. Okay. Or e, I'm sorry, I said that wrong. E to the first power gives us e. And so that's how we compute and get e. E to the first power gives us e. Now we have to evaluate at e, at 1, and at e squared. Now f of e is going to be 10e times 2 minus natural log of e. Natural log of e is 1, so 2 minus 1 is 1, and that gives us 10e. And 10e is approximately 27.18. If you type that into your calculator. We then have to evaluate at 1 and at e squared. When I evaluate at 1, that's going to be 10 times 1 and 2 minus the natural log of 1. Now the natural log of 1 is 0. So I have here 10 times 1 is 10 times 2 is 20. Now obviously this is not the absolute maximum. It could possibly be the absolute minimum, but it's definitely not the maximum. Then evaluate at e squared. So that's 10 times e squared times 2 minus natural log of e squared. Now the natural log of e squared is 2. So I have 10 times 10e squared times 0, which is 0. That tells us our absolute minimum value is going to be 0 at x equals e squared, and our maximum value will be approximately 27.18 at x equals e. Now let's look at a picture of that, and you can see we evaluated at our 2 endpoints and at our critical value. And here is the maximum value at e, comma, 10e. And so that is our maximum. The maximum is 10e. And the minimum absolute value was 0 at e squared. Now let's look at one more example. Let's find the absolute maximum minimum values of f of x equals x to the 2/3. So we have to take the first derivative, the power rule, so that's 2/3, x to the negative 1/3. And now remember that means we have 2/3. And if I take x to the negative 1/3 and move it down to the denominator, it'd be positive 1/3, which is the cube root of x. Now this is never going to be equal to 0. However, it can be undefined. If x is 0, this would be undefined. So this is undefined at x equals 0. So that is a critical value. So when we evaluate here, we have to evaluate it 0, -2, and +3. So we find f of 0, which is our critical value, is 0 to the 2/3, or 0. F of -2 is -2 to the 2/3. Now remember how we do that. We square our -2, because the 2 is the exponent, and then we take the cube root. So if I square -2, I'll have 4 to the 1/3, which is the cube root of 4. Okay, if I do f of 3, that's 3 to the 2/3. So if I square 3, that's 9. So I have 9 to the 1/3, which is the cube root of 9. Now obviously 0 is our minimum. Our maximum value, the cube root of 9, is bigger than the cube root of 4, so our maximum will occur at 3. And here's our picture. Our absolute minimum is here at 0, and it is undefined slope there, and you can see it's at a point. Our maximum is here at 3, and the y value is the cube root of 9.